Welcome to Chapter 5, Special Types. We begin this chapter by exploring none, a unique constant in Python used to represent the absence of a value. Understanding none is crucial for handling defaults and function return values. 1. Definition and type. None is a single value, a constant defined by Python. It is not zero, it is not an empty string, and it is not false. It belongs to its own data type, none type. 2. None in functions. By default, if a function does not have an explicit return statement, Python automatically returns none. None is often used as a default value for optional function arguments, allowing the code to later check if a value was actually passed by the user. 3. Comparison with none. When checking if a variable is none, the preferred and most robust method is to use the identity operator, is. To summarize, none is Python's way of saying no value here. Use it for initializing variables, defining default arguments, and checking the return status of functions that don't explicitly return data. In our next lecture, 0502, Escape Chars, we will learn how to deal with special characters within strings that are usually difficult to represent directly, like quotes or new lines. See you there. Welcome back. When working with strings in Python, you often encounter situations where you need to include special characters, such as quotes or new lines, that normally terminate the string. This is where escape characters come in, allowing you to insert these literal symbols using a backslash. 1. Escaping quotes. A common use case is inserting a quote inside a string that is defined by the same type of quote. We use a backslash to tell Python to treat the quote literally. 2. Common escape sequences. Besides quotes, Python supports several common escape sequences for formatting and special characters. So backslash n inserts a new line and backslash t inserts a horizontal tab space. 3. The raw string. When dealing with file paths, especially on Windows, or when using regular expressions, Python's default interpretation of backslashes can lead to errors, as you saw with the truncated Unicode escape. The solution is the raw string. By prefixing the string with r, we instruct Python to treat every backslash literally, resolving the Unicode error and correctly representing the file path. To summarize, use the backslash to escape characters and insert special formatting. Use raw strings when you need to treat backslashes as literal characters, particularly for file paths or complex patterns, to avoid unexpected syntax errors. In our next lecture, 0503, Constants, we will discuss how to define and use constants in Python, a concept important for writing clean and maintainable code. See you there. Welcome back. In many programming languages, a constant is a variable whose value cannot be changed after assignment. However, Python does not have true, built-in constants. Instead, it relies on strict naming conventions and developer discipline to define values that should remain fixed. 1. The Python convention. To signify that a variable should be treated as a constant, Python programmers use a naming convention known as screaming snake case. This means using all capital letters, with underscores separating words. When another programmer sees a variable named like this, they understand that its value should not be modified during the program's execution. 2. Constants versus variables. It is important to remember that this is only a convention. Python will not prevent you from reassigning a constant's value. This means the enforcement is purely voluntary and relies on developer discipline. Always respect the screaming snake case convention to maintain code clarity and integrity. 3. A good practice. For large projects, it is a good practice to define all constants in a single, dedicated file, often named constants.py. This centralized location makes them easy to manage and import across your entire codebase. To summarize, use Screaming Snake Case for constants to communicate intent to other developers. Although Python permits changes, maintaining the value ensures the integrity of your fixed settings. We have defined constants using convention. In our next lecture, 05.04, del keyword, we will learn how to permanently delete references to objects and objects themselves from Python's memory. See you there! Welcome back. The del keyword is a powerful but often misunderstood tool in Python. It stands for delete, and its primary purpose is to remove names or references from the program's scope. This often leads to the deletion of the underlying object from memory. 1. Deleting a variable reference. When you use del on a variable, you are deleting the name that points to the object, not necessarily the object itself. Once the name is deleted, trying to access it will result in a name error. If the object has no more references pointing to it after the deletion, Python's garbage collector will automatically remove the object from memory. 2. Deleting items from sequences. The del keyword is one of the standard ways to remove elements from mutable sequence types, such as lists and dictionaries, using either an index or a key. To summarize, the del keyword is used to remove a name from the current namespace. When used on sequences, it removes elements based on index or key. If the underlying object has no more references, it is marked for garbage collection. This completes our look at individual special types. Our next lecture, 05.05, Data Type Summary. See you there. Congratulations! We have now completed our comprehensive study of Python's core data types. This final lecture of the chapter will summarize something we have learned, providing you with a mini sheet to choose the right type for your data. Let's look at the big picture. The most critical attributes to remember are mutability, can it change, and order, is it indexed? Note that while dictionaries preserve insertion order in modern Python, they are technically accessed by key, not by numerical index. When deciding which type to use, categorize them by their behavior. Use these when your data needs to be modified, extended, or updated frequently. Use these for fixed data constants, dictionary keys, or when you need to ensure data safety. Finally, remember the special utility types we covered in this chapter. You now possess the building blocks of Python. The next step is learning how to manipulate these blocks using operators. We are now moving to Chapter 6, Operators and Operands. We will start with Lecture 06.01, Arithmetic Operators. See you there.